right, sounds good. Well, I wanted to thank everybody for joining us today. This is a special webinar we're doing. We haven't really had a chance to talk with our startups, so I want to thank all the people in our startup program who've been using 3D Experience SOLIDWORKS and the 3D Experience platform in the early stages of your company. So we wanted to do this for a little while, talk about simulation, talk about the capabilities that we have, but then also give everybody just a general awareness of this program. So I want to introduce my colleague Dana Parrish. He's my fellow Sim brother, as I like to call him. We'll be presenting today along with Roland Willis, who heads up our entrepreneur program. So some of you might have worked with Roland in the past. And then we're also joined, and he's going to be answering a lot of the questions that you guys might have. Our good friend Reza, one of our resident smart people here to help answer a lot of the technical questions and everything. So as you guys have questions, there is a Q&A section. So feel free to type any questions. We'll try to get to them during this. If we can't get during, we'll take some time, probably about 5-10 minutes afterwards to answer some of those questions as well. So let's go ahead and get started with our agenda today. So see here, that advances. There we go. All right. So my friend Dana is going to be talking about why we're here today. Why do we simulate? Why it's important? All the great things that you can do with it. So he'll go through that. We'll also talk about how using some more of these advanced design tools along with our advanced simulation, how it's going to help you design better, more innovative products, what it means on the 3D Experience platform, the tools that we have available, which are for structures, electromagnetics, and fluids. And then Roland's going to finish by talking about our startup program and what's available to you guys through that. And then we'll finish up at the very end. A couple little notes on this that we will want your feedback because we're not, like I said, we're not going to do a technical deep dive today on these different domains that you see here. We'll do those in follow-up sessions, but we'll want your feedback on some of the things that you'd like to see. So a lot of people probably here, this kind of funny picture of my sim brother Dana and I here, but a lot of people are thinking about, do I make the jump into simulation? Is this something I'm going to start my company doing everything? So Dana, I'm going to turn it over to you now. Can you talk a little bit more about how these advanced tools, how they can help these companies make more innovative products?
Absolutely, absolutely. So good morning, everybody. I'm Dana, and really appreciate you coming out and spending some time with us. And we firmly believe at the end of the day, for the why part of this presentation, that simulation powers innovation. As a startup, as you guys are, putting your business together and trying to innovate and create new and cutting edge products, the simulation powers the innovation side of that. You got to try a lot of different things. You got to try to improve things, make things better. And so that innovation comes from a lot of trends that we're seeing out there in the market space today. When you look at electric vehicles, you look at transportation and mobility, additive manufacturing, the virtual reality, the Internet of Things, connected cities, connected products, robotics, all that stuff. These are all these trends that are driving innovation today, driving new and really cool products, and also driving the need for simulation to go hand in hand with your design, with your actual designing of the product. And on top of that, some more advanced simulation that can take advantage of what we have today in the cloud. So at the end of the day, the why of simulation. Simulation is answering important questions as they pop up here, right? Can I improve my design? Will it break? Will it leak? How long can I make it last? Will it last? Can I take out materials? If there's any type of government testing, can I pass it through there? Can I try different materials? Is my product safe? There's a lot of there's more questions, of course, but that's the type of question simulation is going to answer in this virtual space without really trying to build an initial prototype. Simulation will never eliminate prototypes by any stretch of the imagination, but you're going to eliminate unnecessary prototypes because you weren't able to answer these questions without building it. And as an entrepreneur, as a startup, right, it's all about better, faster, cheaper. So how does simulation help you with that? Can I make a better product? Can I build it faster and make it cheaper? Well, first off, it's getting the product right the first time. So the better, the BFC, but that takes into account everything there, better, faster, cheaper, enabling you to beat the competition. You're controlling product release and obsolescence, and you're avoiding the bottlenecks. And then you're also diminishing the guessing, the outsourcing. We have a lot of customers that have been customers for us for a long time that are moving to simulation because of the fact that they've been outsourcing for years. They now want to bring it in-house because of the time and the costs involved. And ultimately, as you're putting new products out, you're designing and innovating new products, right? The customers you're going to be selling to they want to be the safest, the best, the most cost efficient solution. And that's probably the biggest driver of this better, faster, cheaper mantra is your customers. This is
Mhm.
what customers are looking at today. This is what customers need and want. So our proposition is this. Today, a lot of folks design what we call in a very serial process. You start with an idea, you start sketching some things out, then you whip out SOLIDWORKS and you do your detailed product design. Then at some point down the road, you're creating maybe some documentation, and then you're doing simulation. Now that simulation can be done through either an outsource, you're building something, sending it to the lab, what have you. Then off it goes to what we call operations, which is the next steps, right? Manufacturing and getting it all out the door. What we're saying is this: with the 3D experience platform and the 3D experience simulation tools in particular, we're bringing that up front where changes are easiest to make and cost the least amount of time and money because you're doing design and detail at the same time. And when you're doing that, you're making much better business decisions because you have this information way ahead of time. And you can then pivot at certain points. Do I turn right with my design? Do I turn left with my design? Or is it I'm right on the straight and narrow and I'm heading right down this highway and everything is looking great? So you're making better business decisions. Now, I used to work years and years ago for Hewlett Packard. And this is actually a chart that I pulled out of that from one of the presentations I used to do, talking about the prototyping and simulation and design and things like that. And at the time they were doing what was called simulation driven design and engineering. I think that term still plays very well today.
Mhm.
Doing simulation upfront where the changes are least amount of time and money, that means you're getting more information at a lot less risk. So do all your simulation and your design up front rather than further down where the costs really start to get exponentially more expensive. The worst thing you can do is, just go right from design into a conventional build, design, and test, because if something happens, you can spend up to 1,000 to 20,000 if you're in full
Mhm.
production changing and fixing things.
Exactly.
Whereas up front, there's nothing really. You're just doing things all in a virtual environment. You're creating what we like to call a virtual twin. It's kind of the actual real product, but in this virtual world where you're putting real world things to it. And
Mhm.
more information, less risk. That's exactly what you want with
Yep.
simulation. And that's our
And
value proposition at the end of the day.
And I think it's even stronger for our startups. I mean, a
Yes.
lot of people, it's not like you've had a product out there years. I think this is hugely important for companies that are just getting off the ground in their product development process. So I agree, and I'm actually going to talk about an example of this in a little while too, Dana, on what happened to a company who
Sure.
found out kind of later in the process what it's like and what it costs. Um,
Yeah, very famous
so
company that we all know and love, I think.
exactly, right? So the way we go about this, I think everyone on the call today is probably familiar with Dassault systems and our brands. This is kind of the compass. If you're using our tools, you've seen this thing. And what's great about the 3D Experience platform, it's where we're putting together the best of all these different tools. So a lot of the people on call have used SolidWorks, and you're using 3D Experience SolidWorks today. A lot of the tools that we use in the pre-processing, so if you're familiar with the meshing, all that kind of stuff when it comes to simulation, those come from another brand of ours, Katia. And then the basis and kind of the star of what we're talking about today is our Simulia brand here. So the great thing about the campus again is we're bringing the best of all these different brands here at Dassault Systems together in one common environment, which is really, really exciting. And for those of you who are not familiar, Dassault has a very long commitment to simulation. We've made a number of acquisitions over years. If you've ever used SolidWorks simulation, They acquired that Cosmos tool back in the early 2000 range. The two main tools we'll talk about today are Abacus, which is the structural solver, and then CST, which is our full set of electromagnetic solvers for electromagnetic simulation. But there's a very long commitment to simulation. We're going to continue to make acquisitions, but this kind of lets you know kind of where we've been and where we're going when it comes to simulation. So five main areas we're going to be looking at today. I mentioned Abacus and CST. Those are our structures and electromagnetic solvers. Fluids, Dana's going to talk about that, what we have on that side of it, because we know computational fluid dynamics is important to a lot of you. Dana's going to go through also the benefits that the platform has when it comes to simulation in our simulation users. I'm going to talk briefly about cloud computing and how it helps companies do a lot of this development faster as well. So starting off with Abacus, kind of the star of the show. And we're not going to do a deep dive on this today, but Abacus is the foundation to our simulated tools. It's the world's technology leading suite of finite element analysis software. Really specifically, it's good for nonlinear applications. So things that are very like stretchy. Think of like a rubber band, different things like that. All different kind of plastics. Also very good at general contact. So you know two different contacts are coming together. You kind of see something like in a car crash, advanced complex or contact situations. This Abacus is fantastic for it. You're starting to see on the screen a few of the drop tests. That would be called explicit analysis. So things that happen in a short amount of time with a lot of energy. This tool is fantastic for it. This slide is kind of like a better one, just kind of show everything at once, but just some different type of applications. You see a few more when it comes to the explicit solver, which is like the bird strike, the drop testing, all that's for our explicit solver. The other thing we can do with this too is some manufacturing type of applications. So riveting operations, sheet metal, things we couldn't do with tools in the past. The Abacus solver allows us to do a lot of these things we couldn't do in the past. And if anyone's ever done any kind of wire crimping, you heard me on the last slide talk about contact problems. Things like this are very easy to do with Abacus. You kind of just set it to run and it does it for you. So if you have any of these type of applications, all the tools on the 3D Experience platform for structures are all powered by Abacus. All right. And I think, Dana, maybe the next thing would be talk about a customer, right, that's been using these tools for the past few years. Can you
Yeah, absolutely. Yeah. So we're gonna talk about this company called PES. This is a one I was personally involved in, and we want to go ahead and let the video play, and then I'll come back and comment on what the success they had. So take it away.
Practical Engineering Solutions is a multi-state licensed engineering firm. Pre-pandemic, we were probably near 100% oil and gas, but pandemic hits, economy kind of crashes a bit, right? We really were in a adapt or die scenario. And I'm proud to say today we're probably 50% oil and gas and 50% other opportunities. Today, PES operates in the direct lithium extraction business. We've done a lot in the marine, offshore, vessel structure type engineering. We've done a little bit of carbon capture, and then we've worked in salt mines in and around Louisiana. We really have diversified.
Oh, shoot, dang it. Did that stop? Yep, sorry about that, Dana. I'll fast forward there.
Okay.
One of the first questions they're gonna say, I needed it last week. The time it takes to get the raw materials to build something has elongated so much that when they come to us, this stuff started 2 weeks ago. So we're gonna give you the shortest delivery we can. So SOLIDWORKS was the main platform.
Sorry. My apologies there, Dana. Okay, yeah.
You broke YouTube, right?
I think it did, right?
With the company I interned with and started my first job with coming out of school, the main simulation tool that we used on all of our designs came out of the simulation suite on the desktop with SOLIDWORKS. It's a really great tool. It has some really good features that really kind of get you introduced into the simulation world. Perfect timing, kind of lined up with our reseller. We had to renew our subscriptions. He came back to us and said, hey, we have this software called Simulia. They told us what it could do. That's what started us on this journey. And it was a program built by Dassault to integrate with SOLIDWORKS. And so there wasn't any third-party nonsense going on. It reduces your time to get up to speed in it because they thought about these things as they developed the software. And so you could say, you know, I need 6 check marks. Pull this open, I need a mesh. Okay, I got a mesh, I got my materials, check mark. I can send that product back to the modeling space, or I can translate and communicate any changes I want to see based on the results in Simulia. I don't have to start over again. And that's a very powerful thing. As a small engineering firm, we need to be lean. We don't have the real estate to go and buy a new server to run these heavier FEAs. By adopting the cloud capabilities of the platform, we can operate like one of these bigger companies with the cloud because we have the horsepower to be able to do so. And if we come to the point where we're solving a problem that the out-the-box solution, the 8 cores, can't get, we can make a phone call, get a quote, and be able to increase the amount of cores that we can solve on. So our return on our investment, we've taken on more complex engineering projects, just with the abilities of the platform compared to what we had before. We haven't gotten a problem that we couldn't solve in the platform.
Great. So this PES, I think Todd mentioned, engineering services company out of Lafayette, Louisiana. I was part of the whole, helping them get the 3D experience simulation tools into their hands. So they did already have our desktop simulation tools, which are really good for what they do. They do a great job, but they needed more, and they needed to do it fast. Like he said, they're getting stuff at the last minute, and their customers expect a very quick turnaround time. So this was a perfect, right up their alley for them. And fast forward to today, they started doing this a couple of years ago. They got their ROI after one consulting project, but the great thing is because it's so flexible, as projects come in, they ramp up or ramp down. They keep one seat of our what's called structural performance engineer. They keep that on site, on staff, if you want to call it that, year round. But as jobs come up, they may get a 3-month license of our fluids tool, or maybe an extra structural performance engineer, and they're able to turn things on and off. So they're super flexible. They can pivot anywhere they need to go because of the fact they're in the cloud. They have super powerful tools based upon the Abacus solver, and you can see the results here. And they're branching out, like he said, they're branching out from oil and gas. They're actually starting to get into some more high-tech type things. We're talking to them right now about our electromagnetics tool that Eric is going to jump into right now.
It's like you were leading me to that, Dana.
Yeah, that's right, and it's true. And I'm segueing you right into it. So, ladies and gentlemen, Eric with electromagnetics.
And in electromagnetics, it's kind of interesting. And what something, when I got into this industry probably about 10, 15 years ago, we didn't talk about electromagnetics very often. But as I think everyone can tell, what's happening these days is everything's becoming more and more connected. Our phones, I can control my thermostat, my garage from my phone. Everything seems to have like a board, some kind of electromagnetics in it. So the need for electromagnetic simulation, and I like to call it the black magic of simulation because you can't actually see it, but it is happening there in the background. It's become more and more important. And I'll give you an example of that after this. But this kind of gives a general overview of the different capabilities, going from the low frequency side, things like sensors, magnets, electric motors, up to high frequency application. And when I say high frequency, we're talking about microwave components, antennas. It seems like everything in the next 5-10 years is going to have some kind of antenna in it. So knowing where to place the antennas, how it's going to communicate with other ones in the area, all that kind of stuff is going to be more and more important. as our products just become more complex. And then, as I mentioned earlier, seems like everything has a printed circuit board in it these days. So with our electromagnetics tools, we can look at things like signal, power, thermal integrity, electromagnetic compatibility, if you're familiar with all that kind of stuff, along with electronics cooling. So, the heat that's generated by these boards, what's it going to do to everything around it? So an interesting example of electromagnetic simulation, I'm not sure if you guys remember the iPhone 4. There was a fatal hardware flaw. And the story behind this is they placed the antenna in the wrong spot on the phone. So when people held the phone, you kind of see that picture on the bottom there, they would hold their phone there, they would lose the signal. So initially, everyone's like, well, just don't hold the phone there. But that wasn't really a good way to fix this. So because of this, they didn't know this ahead of time. It caused quite a bit of both time issues, but also a lot of money that was involved. So what they ended up doing was they sent everybody this case that fixed the problem. But this ended up costing, and maybe to Apple, $175 million wasn't that big of a deal. But you kind of get the idea that this was a very expensive problem. It hurt them, not just in the money that was lost during that, but also just in the you think about the market share, just what people thought of the products and everything like that. So this is a short, quick example of electromagnetic simulation and some of the problems we can see ahead of time. Before, I think Dana had that slide earlier in his where it showed, if you do this at this time, but if you wait till the end, it could be 1,000 times more expensive if you wait. So this could have just been something they saw via simulation, that they move the antenna to a better spot, and then they never have this problem. So with that, Dana, I'm going to let you talk about fluids and
Okay, perfect.
our,
So, so we've gone through structures, we've looked at electromagnetics, and now we have to look at the last piece of simulation physics that kind of completes the whole picture of our simulation tools. It's called Fluid Dynamics Engineer, and some of the things that we find from our customers is, CFD is very compute intensive. Being able to get things done quickly is very important and accurately. So, a couple things we add into this thing. So, definitely a very fast turnaround time because it's all embedded. It's all part of the platform, and then design exploration, right? Being able to do trade-off studies. There's some automated tools for that. So we want to be able to give you guys some automated tools, but also it's been validated for accuracy and efficiency. So you start looking at it's called the RANS type of simulation that it's doing, hex dominant body fitted mesh, laminar turbulent flow, conjugate heat transfer, radiation, all that stuff. So everything is there that's needed for using the cloud to do these CFD calculations because they can be, again, compute and power intensive. So here's some of the things that we have. You want to hit to the next slide.
Yep.
I'm not going to read all these, but we got you covered. Okay, we've got you covered with all the different stuff here. We even added, we have our desktop flow tool. A couple things that differentiate us. We've added more turbulence models. Okay, we've added the near wall modeling, which is really nice because as you get near geometry and you have fluid passing over it, how do you model that interaction between the geometry and the fluid, that little tiny interaction piece? We're able to handle that very well now. It's very, we do lots of body fitted meshing, mesh morphing. It's a really, really great tool. And again, it really takes advantage of the platform, of the amount of cores, as well as what's out there in the cloud. So speaking of that, let's talk about the platform. What makes the platform unique and different? It is what it is. It's a collaborative space and environment. It's a platform, so to speak, where people can come together, regardless of your location, what your responsibility is, what you're trying to accomplish, what have you. You can bring as many or as few people you want onto your project. And especially as a startup entrepreneur type thing, you might have people spread out across the world helping you. And how do you bring them together? How do you bring them into this one environment where you can look at a simulation result and collaborate on it and provide feedback, whether it's good or bad, or make some changes? How do you do that effectively? It used to be Dropbox and all this other stuff. Well, no, all get together in a secure environment. And there's three layers of the 3D Experience platform: infrastructure, platform, and software. Everyone is a service. Each has their own layer of security. So the infrastructure we provide, that's all the servers, all the hosting, the storage, everything there that to run the 3D Experience platform. Then you look at the platform itself. That's the uh, actual, I guess, if you want to call it your iPhone that you actually have, that is there for you now to put all your apps on top of it, which now turns into the software as a service piece. That's all the applications. And we already talked about the structure application, the electromagnetics application, and the fluids application. So those are the applications that sit on top of the platform. Think of the platform as your iPhone, and the simulation as your apps that you put onto your iPhone.
Absolutely.
All secure inside the infrastructure, with all the servers, all in secure location, all different levels of security. If you guys ever have insomnia, we have lots of white papers that'll put you right to sleep with all the details of what that entails.
Exactly. And I think to our startups and entrepreneur customers, this is a very important thing. Not everyone has their own IT, company or internal people. So being able to have this as a service is such a huge advantage. To companies that are just getting off the ground. Maybe in time you'll have bigger departments to kind of do some of this, but being able to, have this to flip a switch and you have all this at your fingertips is great. And one of the biggest thing, and you heard Tyler talk about it in the PES story, was the cloud compute capability. Historically, cloud compute was only available to very large companies that had the revenues and stuff like that to be able to afford, HPC, which is high performance computing clusters, to do these type of simulations. Well, with the cloud, through 3D Experience, we have the ability to give you guys that same kind of power. I just want to go through a couple of quick examples. This one's on the electromagnetic side, comparing cloud compute versus local compute. So doing it locally on one core, this solve took 4 hours and 20 minutes. You could see using the out-of-the-box capabilities that we give the 16 cores for electromagnetics, that cut down to 1 hour and 43 minutes. So definitely time-wise, local compute versus cloud compute, half the time. If you want to throw more, as Tyler mentioned, at it, where they'll call up, say, hey, I need to add some credits, I want to solve faster, you could get to the point where you're solving 10 times faster. So depending on your customer needs, what they're pushing you towards, getting the product out the door, having the cloud compute capabilities is a huge key. Another example here, local compute using, I think in this case it was 8 cores, was 26 minutes on, I think fewer was 1. This dropped it down to 16 minutes. So you can already see, using the cloud 4x on the solve time, making it go a whole lot quicker. So, and there's different types of scenarios. I know Dana talked about our fluids tool. Those type of analysis generally take a good amount of time based on what's going on in the background. So having cloud compute for applications like this is very, very important. Kind of a few things to just kind of highlight on it. Just your time, your ability to do, be able to do more simulations. You can get more products done. You can test more things whenever you have the ability to solve faster. So we have some companies that will just throw a ton of different types of analysis at our cloud. That way they can kind of figure out which one is best for them. But, in the old days for them, that might have taken weeks, where they're doing it in hours or days now. So I think the next area we're going to talk about is actually, overall, we're about done today. Just want to highlight again the key things that we talked about today. So AppKiss, which is our FEA solver, great for contact problems, great for explicit, analysis. CST, which is our full, I think we actually have 23 solvers in our CST suite. So that's good for all the electromagnetic simulation that your company might be doing or, thinking about doing down the road. Dana talked about our fluids applications, our CFD analysis, the benefits of the platform, and then last, again, what cloud computing can do for you. So I mentioned at the beginning, this wasn't a technical deep dive. We want to take our future sessions and do deeper dives technically. So we'll have like our smart person like Reza do those type of presentations for us down the road. So I wanted to set a poll question. Let me see if I can launch it here and get your guys' feedback. Dean, are you able to launch the poll there for me? I am not. Let's see here.
Hold on, let me see. Polls, quizzes. Yep, I got it here.
Got it. Okay. So if you could give us your feedback on what you would like to see next, and then we'll help. This will help us drive what we're going to do in our next session, whether it's solving simulation using electromagnetics, if you look more at high performance computing, solving complex contact or explicit structural problems, CFD, or nothing at all. So just kind of give us what your feedback is here. And it looks like we have it's an early race. It's looking like structures and electromagnetics are going back and forth. Now electromagnetics took over.
Oh, now we're tied.
It's like neck and neck.
It's like watching the horses. It's like watching a horse race.
Hey, it's like a horse race here. So we're trying to see. I'm going to give everyone a.
Which one's going to win?
This, you know, you're going to make it difficult on us and make it a tie. So we're going to have to.
I threw $50 on structures, so I don't know. I guess I'm out.
Oh wow, yeah, we'll have to see. All right, well, looks like it's going to be a tie. Ooh, let's see if anyone else. No, I thought we might have a tie. Oh nope. See, we had one more for each still. All right, it looks like it still looks like it's a tie. See, it's
wow.
No, we're going back and forth there. Going once, going twice. All right, where it looks like we have tied. So Daniel, we'll have to flip a coin on that, figure out. But watch your email. In the coming weeks, we will set up a follow-up session, and we're gonna cover all these topics. So we will hit electromagnetics, we will hit structures, we will hit fluids. So if you don't get to see it on the first one, we'll make sure there's a second session. So with that, I'll just share the results there real quick that everyone can see where we ended up there. So I wasn't lying. It was a horse race the whole time there.
Mm-hmm.
All right. So
Great.
Roland, I'm going to turn it over to you now to talk about the startup program and what it means to them. I think everyone here is part of that program most likely, but if not, they'll learn something new as well.
For sure. All right. Good morning, good afternoon, or good evening, depending on where you might be calling from. Welcome. I'm Roland Willis. I manage the SOLIDWORKS for Startups program here in North America. And as Dana and Eric mentioned throughout this overview, the 3D Experience platform clearly provides a wealth of capabilities that will help you validate your product design. So, as we all know, you folks are living it. Startups often begin with an idea, and it takes time and money and obviously resources to bring that idea to life. And the SOLIDWORKS for Startups program is designed to provide you really with a head start toward achieving those product ambitions. So most, if not all, of the capabilities that were discussed during today's overview are available to participating startups either at no cost or at significant discounts. So if there's some interest in looking into these further, please reach out to me offline. I'll have my contact information, but you will have the ability to conduct CFD, as they mentioned, linear and nonlinear, electromagnetics, we just talked about that, and a whole host of other things, even further away from what I mentioned here. So, so many of you already know about and hopefully are already participating in the SOLIDWORKS for Startups program, and we really appreciate that. Thanks. We're absolutely thrilled to have you with us. If there are any folks on this call that might be interested that haven't taken part, it's a 3-year program for early to mid-stage startups who've been in business less than 5 years and whose funding or revenue is less than 5 million. So if you're interested in learning more, please reach out to me. My contact is right here. I'm more than happy to help answer any questions you might have. And thanks again. We really appreciate your taking part. Okay, I'll turn it back to you guys. Thanks, Eric.
Roland, do you want to put yours back up there real quick? Just give everyone, I want to make sure everyone was able to get your email and that web address there
sure.
real quick.
Just go back.
I just want to give them, before we jump into the Q&A.
Sure.
We want to just share that real quick. And then I'll. Are you sharing that, Roland?
Oh, I'm sorry. Did I? Yep.
No
I
worries.
must have. Let's share. All right. Just a moment, folks.
No worries.
All right. Okay. Oops.
There you go. They should be able to see it there. So
Good.
roland.willis@3ds.com, and then you can apply at SOLIDWORKS.com
Yep.
startups. So just want to make sure everyone got a chance to see that if you're not already in the program. And this is great. And like I said, a lot of these tools, are very important in the startup stages. And simulation obviously is a huge part of that, as we talked about today. So with that, I want to open up.
Eric, there are a couple of questions.
Yeah, why don't all right, so open up for questions.
Do you want me to go ahead and answer?
Yeah, why don't you go ahead and the ones that we've already gotten and answered, and then any additional ones we can take as well.
Right. Okay. So there are a couple of them. Let me cover that, and then if there's anything in addition, Eric or colleagues, you can take it up. So the first question is somebody asked, okay, can wood structures be simulated within the 3D experience, platform, if you like? So basically, the short answer is yes. But kind of expanding on that answer a little bit is that it really comes down to what type of analysis you want to do. There is nothing really, obviously, wood in terms of the behavior, we know it's kind of autotropic, but really it comes down to what type of analysis you want to do. On the structural side, we have 6 different roles, and they have different capabilities. So if you want to do wood or any other material, just linear analysis, there are some, basic roles. If you want to do nonlinear, and consider that it goes to higher roles. But in principle, if you go to higher roles, you can do damage modeling, you can do any sorts of kind of fancy material modeling for wood per se, but you can also stay within the linear range, which means it enables you to use the basic packages. So yeah, the short answer is yes, but depending on how far you want to go with the modeling of the wood, in terms of behavior, then you kind of choose what level of the role, what package it's the right solution for you. There is another question. I own utility patents for an automated storage system that will cater to RVs and boats, but I'm a non-technical founder. Can simulation help me in trying to show the concept of the utility patent? Again, the short answer is yes, but if I wanted to kind of elaborate on that a little bit, is that partially the question, it was addressed during the parts of the presentation today in terms of the benefits of simulation. So I would kind of highlight 2 points about this specific question. One is that, again, it depends on what you want to do. Obviously simulation, there is a little bit of learning curve. And depending on whether you want to do some simpler stuff, the learning curve is going to be much shorter. If you want to do some fancier simulation, it's going to be a little bit more in terms of getting used to. Now, obviously, the benefit today is that compared to, let's say, 30 years ago, 30 years ago, you had to be an analyst to kind of approach simulation. Today, with the ease of use, the sophistication of the software, and all of those benefits that are available, you can kind of use simulation at the basic level, especially at the design stage, without being highly technical. So again, it comes down to what level of solution, how much you want to, how deep you want to go. But one additional point also that I want to highlight is that think about the alternative. If you didn't use simulation, what is your alternative? Obviously, you don't want to kind of design something or try to bring it to market without having done anything. If the alternative is only physical testing, think about all those shortcomings and all those disadvantages in terms of physical testing that was mentioned by my colleagues here. So simulation is probably the easiest and the most efficient route for you to take.
Great answer.
Right. There's a third question here about licensing, I mean, I can address that, but Eric, if you want to take it.
Yeah, it
feel
says
free
if I
to do so.
provide my logins to a freelancer who's familiar with our systems, am I able to cancel that login after they've completed the work, but keep the information created as company account? Everything will be, and we could probably talk about in a future one as well. It's all on your company tenant. So you could have someone, and I think we can do it every 30 days. We can turn them off afterwards. So the short answer to that is yes, we would have a way to be able to let them work for you for a little while and then turn it off. And then all this work that they would do for you would be on the cloud. So that is definitely a possibility there. Good question, Jed. Next question, can the simulations handle electromagnetics and gas flow at the same time? Yeah, I mean, and Reza, maybe I'd defer to you on this a little bit, but kind of in a one-way situation, right?
Well, yeah, I mean, it depends. Again, you
Yeah.
know, sometimes, as I was mentioning earlier, you know, the specifics of the question, you know, may kind of change the answer. But let me kind of look at the question a little bit kind of broader in a sense. You can do electromagnetic simulation with this CST solution that was, or electromagnetics engineer that was mentioned already.
Mhm.
Gas flow, it depends on what you are looking at. For example, within the electromagnetics module, you know, if the gas flow, or let's say airflow that you are thinking about is like a PCB, that you have airflow around a chip that kind of it's used to cool it down, then you can do it within that electromagnetics engineer or those CST capabilities. You know, the effect of the air in terms of cooling, you can do that. As a matter of fact, it does have some thermal capabilities specifically that can address those. But if you are looking at the gas flow in terms of the gas flow itself, then it becomes the CFD or flow simulation package. Computational fluid dynamics, that is a different role, that is a different capability that you are looking at. So again, it really kind of comes down to the details of what you are trying to get out of it. You know, sometimes you know, you stay with one package, you do some approximations in terms of the effect of, let's say in this case here, the gas. But again, you know, that's kind of a broader answer, but we can look at your specifics of the application that you're thinking about, and then we can kind of help you out in terms of, okay, what specifically, what level of the package, what solution would be the most appropriate for you.
Yep. Next one is, can one do solar simulation with this? Say from a traditional architectural input file, DWG, Revit, etc.
Okay, so that question also, I'm going to split it into two segments. On the, when you say about traditional architectural input from you know, file DWG, RVT, etc. So when you think about simulation, you can think about two aspects of it. One is on the CAD side of it in terms of the geometry. So when you talk about DWG, there is going to be a stage where, for example, if you wanted to use any of our roles, you have to have the CAD model available. That is basically the starting point in terms of doing simulation. Now, we have tools in terms of bringing a DWG to a solid geometry, and after that, the simulation stage starts. So again, so CAD side of it, that DWG to a solid geometry, that is one aspect of it, and then the simulation side of it starts at that point.
Okay.
Make sense?
Yep. Next question, do you have a sandbox? I'm not quite sure if you're maybe, as it says, do you have a sandbox where I could explore on my own? I'd say on that particular question, reach out to your local partner on that particular question. What they might be able to do is run like a quick proof of concept with you to kind of show, maybe you kind of need to see a little bit more how that works, but your local partner should be able to kind of help you out trying to figure out if it's kind of the right fit for you on that one. And then the last question I'm seeing here is, can you run a CFD simulation for a centrifugal pump? Can't say that word.
Centrifugal pump, yeah. I mean, the short answer is yes.
Question.
Yeah, the short answer is yes. There is a functionality within the CFD the solution. It's called the rotating reference frame that is being used for centrifugal pumps specifically. But yes, the short answer is yes.
Yeah, that's a great one. I've seen a few animations on that, so that would be a good application for this. All right, any other questions before we wrap up? I'll give everyone a minute. We'll stay on for a few more minutes if anyone has any additional questions, but I want to thank everybody for joining us. I hope this was informative. Look forward to seeing our next session. So we'll figure out if that's going to be electromagnetics or structures, but we'll do them all. And then also we're working on making sure everyone can get a copy of the recording of this. So if this is something you want to share, we'll make sure that is available to everybody. If you have someone that you work with that couldn't be on with us today, we'll make sure that that is available as well. So we'll stay on for a few more minutes, but again, thank you very much. We really appreciate everybody.